Hi guys, so the first question we're gonna deal with is really similar to what we did on the introduction to this tutorial, and what we're gonna do actually is, instead of taking this PVC road, we're gonna use marbles on top of a table. So let's draw a table, and for me a table it's just a 2D dimensional, so I can actually put it as a y-axis, right? The location on the y-axis and the location on the x-axis. So this is a table for me. This tells me what the location on each place on the table, so we can follow the marbles we're gonna put on this table. So I put here in the middle a marble. Let's draw it. Here is the marble, and I'm gonna name it A. Marble A. So let's put a table which take into account all the given data. So we have here name of a marble. So this marble gonna be A. Up. And this marble have some charge, QA. And QA is actually equal to 5Q. Let's give it a 5Q. This is gonna be charge. And the last part of the table is the location. Look. And how we gonna present location in a more math kind of form? We can use the vector R. R, which is some x value and y, and if I put it in the origin, the value is 0 and 0 for y and x. I'm gonna put another marble on the table, and because this marble have charge, it's gonna apply force on marble A. So the next one's gonna be marble B. Let's put it here, B. And the location of B, you see that it have some negative value for x and positive value for y. So the value for x is -4 and -3 and +4 for the y. The charge is smaller. Let's put Q, only Q. But you see that it's the same charge. It's the same, sorry, not the same charge, but the same, if this is positive, if Q is positive, so this one is positive. If it's negative, this one is negative. And the name is gonna be B. And the last one is gonna be C. C located, let's put it here. And I do it big and black for two reasons. Big because it's presented, I'm gonna have here a lot of charge. And we're gonna see how this affects it. And black because it's gonna be the other sign. If this positive, this is negative. If Q was negative, so this negative, and this gonna, two minuses, gonna have plus. It's just a way to present it. So this is a thing that I have in mind, cartoonish way to present what is the charge and what is the charge, also the sign and also the magnitude. So this is how we perform it. And the last thing is the location, two positive value. So it's gonna be 6 and 8. Perfect. So that's what we have. This is the given data. This is perfect. And good. And the last thing we're gonna do is to present what is the question. So the question is, what is the value of, let's clean this out, we don't need this one. What is the value of the force? I remind you, force is a magnitude and also a direction that marble B apply on marble A. You see it? So, and you saw in your lecture that this magnitude equal to this closed form, which is QA, the charge that are interested to know what's the force apply on it, multiply by K, some constant, QB, the charge that apply the force, and this divided by, this multiply, first of all, it's divided by something, we're gonna talk in a second, but it's multiplied by this vector. RA, the location of A, minus the location of B, and here's the same, the location of A minus the location of B, but its magnitude, you see it? It's a magnitude of this vector, and also take this magnitude to the power of 3. So this is the equation, and this is really important equation. You're going to use it all the time. Okay? Perfect. And now let's solve it because that's what they want to know. So how I solve this kind of equation? First of all, I'm gonna take care of this vector, of this magnitude. Why? Because when I'm gonna calculate this one, I immediately get the other part of the equation, which I'm also interested in. So let's calculate this one. So we have here RA. What is the location of RA? It's 0, 0 minus this one, which is minus 3, 4. And this equal to plus 3, 4. And minus 4, right? Because this minus got to here. Perfect. And if I want to plug it here, I need first to do the magnitude. So how I can do magnitude to this vector? It's really easy. I just take each component, square it up, right? Square it up, and then take the root of it. And this equal to 5. Perfect. So now I got everything I need from here and here. So this is equal to, let's write it, this equal to QK, QA, QB divided by 5, which is the magnitude, to the third, multiplied by this 3 minus 4 vector. Perfect. So now we have the solution. Beside QA and QB, we're gonna put it in a second. But I want you to notice something. This is only a magnitude, and this vector have also magnitude and also direction. If I want to really separate this vector to have here only the magnitude of the vector and have here only the direction in which the vector is pointing, I need to also divide this one by 5. So I can actually divide this one by its magnitude, divided by 5, but I can't do it to the total force, to all the force, because if I'm gonna do it, I need to compensate for that. So I can also multiply by 5. So this gonna clean this vector to have only direction, but I need also to compensate. So what it's equal to, this one go with this one, so it's gonna be 2. So there are 5, 2. Here we're gonna have this one, it's becoming 0.6 minus 0.8. Perfect. And here we have this K, and we have here QA, which QA we know it's given thing, it's 5Q, and we have here QB, which is also known, it's Q. I can also cancel this one out, and what I left with Q square, K, 5, and the direction, which is 0.6 minus 0.8. So this is the force that the marvel B apply on the marvel A. Let's check that we agree with this solution. So we know that both of the marvels have the same sign, right? So they're gonna apply repulsion force, right? So this marvel B wanna go here and A want to go here. So let's see if this is the case. So we know that this is the magnitude. Let's check the direction. So I see that I have some repulsion to the x direction. Okay, it's good. And I have some negative to the y. Negative to the y. And I can clearly see that the direction is good and I'm in a good way to... I was right about the directions. I have intuitive idea that what I did is right. And that's all. This is the solution. And now we're gonna go to the next question.